Okay, lab number 11, we're going to use the NavShips block or NavC block again, and you can see that there's holes drilled down this way, okay, all the way through. So we're going to go back, and what we're going to do is set our range to 3 inches. Okay, still messing with steel, so that's helpful. So there's 3 inches. Okay, we're right on 3 inches. Now what we want to do with a DAC curve is actually establish a gate that's going to tell us defect sizing. Whoops. So defect sizing of these holes, okay, take another look here. Defect sizing of these holes, these are about 60 thousandths holes. So what we would say is, when we establish this DAC, that we have established a flaw size of 60 thousandths of an inch. Let's back out just a little bit. Okay? And anything larger than 60 thousandths of an inch is going to pop through this gate that we're going to make. So, we're going to set our first signal at 80% screen height. Okay? And I'm just right over the top of that hole right there. Okay? So there's our first signal. Drop it down to 80% screen height. Right there. Now what I'm going to do is make a mark, actual mark on the screen. Okay? I'm going to go to the next one over here. Okay, here's another one. Make a mark on the screen. And now, because of attenuation and sizing, these signals are getting smaller each time. So since we know these signals are getting smaller and smaller, we are trying to size them or make it easier on ourselves to size defects and call good or bad either way. Okay, so I'm just making marks on the screen here like you see. I'm going to turn the block over and come from the other side now. Okay, peaked up, there it is again. So a little more coupling. And as you can tell, we use a bunch of coupling here. Alright. Okay, there's the next one. Get this guy peaked up. Right there. Next guy over here. Okay, that's peaked up. A little more coupling. Whoops. Guess that would make a difference over here. So let's go back over here. Peak him up a little higher. So we'll get rid of this line right there. Next one, right there. Right there. And right there. So now, start over here at 80%. Draw our line all the way down and across. Whoops, I got a little off over there. Actually draw it over there and down. We get rid of this. So now we have a DAC, and anything bigger than that 60 thousandths of an inch defect is going to pop through our gate. So if we come over here and just look at a defect that's bigger than 60 thousandths of an inch, okay, it pops through just barely, but it pops through our gate that we had established. And it's just barely through, but it's through. So that would tell us, hey, you've got a defect bigger than 60 thousandths of an inch. Okay? Just as kind of a question here, 3-inch range, where's that signal coming up at? Just past 10%? That'll be one of your questions for this lab. So, there you see the DAC curve. Just a nice big gate that we've made to tell us sizes of defects.